For today's lesson, we're going to look at evaluating summation notation expressions. So what you see on the screen is a unique symbol. In fact, that backwards E that you see, that's called sigma. It's an alphabet letter of the Greek alphabet. It's specifically capital sigma. And when you're looking at these today, what this represents, you're always going to be given some kind of equation next to that symbol. The bottom number represents the number that you want to start plugging in to that equation. And then the top number represents the last number you're going to plug in. And what that notation represents is actually the sum of all those outputs if you plug those numbers in. And when we're going to plug numbers in today, it's going to be the bottom number to the top number. It's all integer values that you're going to be plugging in. So what this looks like, if I were to evaluate this, the first step we got to do is expand what this looks like. And so if I start by plugging in 1, again, for this equation, and our equation here is k squared, what that's going to look like is 1 squared. And then we add a plus symbol because that sigma notation, that backwards E, represents a sum of all the things, so adding everything up. And then we move to the next integer above 1, which is 2. And I plug 2 in for that equation, so it'd be 2 squared. And then I plug in 3 for that equation, 3 squared. And then I plug in 4, and then I plug in 5. And then lastly, that top number says I'm going to stop by plugging in 6. That's what the expanded form of what that notation looks like. And then when I evaluate now, well, order of operations, we can just work each number separately. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth. And then we can add these up on our calculator. And when you do that, I think you should get a total answer of 91, and that would be our final answer. So what we're looking for today is that you are showing us the expanded form, and then you're taking that and coming up with the correct answer in the end. So our answers in the end are going to be numerical values, and so let's get some practice. So let's take a look at another one together. So if we notice, this notation looks like we got the equation m times m plus 2 for our formula that we're looking at today, or for this one. And then so the bottom number, notice, starts at 0. So that means I'm going to, for the expanding part, I'm going to show that I'm subbing in 0 for m. So it'll be 0 times 0 plus 2. So I'd be plugging in 0. Remember that sigma notation, that backwards E, that represents adding. So I'm going to put a plus sign, and then I'm going to move to the next integer above 0, which is 1. So if I plug in 1 for m, it's going to be 1 times 1 plus 2. And then if I plug in the next integer of 2, then it's going to be 2 times 2 plus 2. And then it's going to be 3 times 3 plus 2. I want to sub in 4. And then notice we're going to stop because the last number is 5 that I want to sub in for m. Then, after we expand, we're going to calculate this. So you can use your calculator if you want. But it looks like in the first one we get 0 plus 1 times 3, and the next one would give us 3 plus 2 times 4, and the next one would give us 8. And then if you look at the next one there, we got 3 times, looks like 5. That ends up being 15. Then it's 4 times 6, which would be 24. And then lastly, 5 times 7, which is 35. And so if we add all those up, looks like you get an answer of 85, and that would be my final answer here. So let's take a look at one more before I have you guys try one on your own. So again, here's our formula, n plus 1 all over 2. And so the first number I want to sub in is 2. So what that's going to look like for the expanding part would be, it looks like 2 plus 1 over 2 plus, then I move to the next integer, which would be 3. And if I sub that in for n, that'd be 3 plus 1 over 2. And then I have to sub in 4 for n. I have to sub in 5 for n. I have to sub in 6, 7, and then I stop at 8 because 8's my top number there. If I evaluate this part now, the first one I get 3 divided by 2, so let's just leave it as 3 over 2. The next term, which is this one here, I get, looks like 3 plus 1 is 2, or 3 plus 1 is 4, but divided by 2 gives me 2. And then if I move to the next term, that's looks like 5 over 2. And then if I move to the next one, that ends up being 6 divided by 2, which is 3. And then I move to the next one, that's 7 divided by 2, so that's going to be 7 over 2. And then it's 8 over 2, which would be 4. And then lastly, 9 divided by 2, which I'm just going to leave as 9 divided by 2. So now if you're going to calculate this and add them all up, you can use your calculator here. But it looks like if you were to add these up, you get a total answer of 21. So I want you to pause the video and see if you can try to get the correct answer for this one. Good luck. So if we take a look at our answer here, notice the first number I'm going to plug in for that equation for n is going to be 3. And so for the expanding part, it's going to be 3 times 3 minus 1 plus, if I look at the next one over, which would be 4, it'd be 3 times 4 minus 1 plus, then I'm plugging in 5, then I'm plugging in 6, and lastly, I'm plugging in 7. So if I go term by term, take a look at the first one, that'd be 9 minus 1 inside there, so that ends up giving me 8, plus, move into the next one, that'd be 12 minus 1, which would be 11, plus, looks like 15 minus 1 for that third term, so it'd be 14, plus, looks like 18 minus 1, which would be 17, plus last term would be 21 minus 1, which is 20. And so if you add all those up, you should have got a total of 70, it looks like. So that really concludes our short little lesson today. So you can get to practicing on the worksheet, and then don't forget to submit that homework quiz before midnight. Have a great rest of your day.